Hello dear students, I am Vikram Nallavade, Assistant Professor working in Department of Mechanical Engineering at Sharad Institute of Technology, College of Engineering, Yadra, Itsal, Kanji. In today's lecture we will cover basics of automobile engineering. So these are the contents, the objectives of today's lecture and basic component of an automobile. So objective, that is to know and study various components of an automobile. See, this is the basic layout of an automobile mentioned here, and various components of an automobile which we need to understand are mentioned here. Here this is the basic structure, or we can say the frame over which entire units are superimposed or present over it, and then over this unit, this is the power plant, the source of energy to run all the mechanisms, that is engine. It is connected with clutch via crankshaft, and then it is again it is connected with the transmission system which drives entire mechanism. Then it is connected with the differential gearbox with the help of a propeller shaft via universal joints. This is the rear axle, this is the front axle, four wheels are represented here, and this is the frame. So in this lecture we will understand about basic structure, power plant, transmission system, auxiliaries, and various controls. The first 5 points are these constitute automobile chassis, and sixth, the superstructure we will discuss. So let's start from the basic structure. As in previous diagram we have understood, this is the frame over which all the parts, engine, transmission box, and differential gearbox, these are mounted over it. So that is the basic structure. So this is the unit. So in this unit all the remainder of the parts required to turn it in a power operated vehicle. So that is most important part. So the chassis of an automobile consists of following components that we have just cleared, that is engine and radiator, then transmission system which includes clutches, gearboxes, propeller shafts, and the rear axle. Here the suspension system is also a part of basic structure, then steering system, brakes, and fuel tank. Most of the important points we'll cover in this lecture and coming lecture one by one. So what are the functions of the basic structure? Generally the basic function we understood, that is to support the chassis components and the body. So in previous diagram you just observe that all the components, engines, transmission system, differential system, and this is connected with the rear axle. So all these are supported by this frame. Then second function is to withstand static and dynamic load without undue deflection or distortion. We all know when entire vehicle is moving onto the ground, then due to some of the uneven surfaces or uneven power generation, many more vibrations are developed. In that condition, all the static and dynamic loads are considered, and all the deflections and vibrations are absorbed by the frame itself. So what type of loads are acting on the frame we'll discuss here. First is the load of the vehicle, means weight of the vehicle. We all know that weight always acts downwards. So along with the weight of the vehicle, the passengers, the occupants, and the luggage is kept in that vehicle. The weight is vertical bending of the side member it happens. So all these deflections, we need to understand what happens due to various types of loads carried by the vehicle. Then vertical loads when vehicle comes across a bump. So this is also the thing which need to be considered, due to which longitudinal torsion is developed due to on wheel lifted. So we all know that road cannot be even all the time. So the moment of the wheel can be lifted individually. So due to which vertical load is applied, and longitudinal torsion due to on wheel lifted it happens. The third type of load we will consider here, that is load due to road camber. It is the angle between the various axes with the wheel of the automobile. So in various conditions. Then side wind and cornering forces. So these are some of the variations due to which the load is applied on to the vehicle, and the lateral bending of side members takes place. Fourth is load due to the wheel impact with road obstacles. Generally we now discuss that road may not be even, so in zigzag path and many more obstacles may be there, due to which what happens, the frame may be changed into parallelogram. Means little bit shape can be changed, but such type of loads, vibrations are absorbed by the frame. Then fifth load, we'll consider that engine torque and braking torque, tending to bend side member in vertical plane. So when engine starts, how much energy, how much power is required, and similarly the power while braking, while stopping the motion of the vehicle, due to which the side members are also affected, that is in vertical plane. And next load we'll consider sudden impact loads during the collision. That is also very important because not always all the conditions are satisfied, but the collisions are also need to be considered. So in this collision, whatever the impact load is affecting the structure of the frame, that also affects the strength and various possibilities. So there are two types of frames. One is conventional and second is integral, or it is also called frameless. In conventional, this is the diagram which represents the conventional frame. So what thing you will observe here, that this is the common case of frame is used in very heavy transport vehicles or all other kind of heavy vehicles. So this is the frame over which all the parts we discussed earlier are superimposed or fitted over it: engine, transmission system, differential gearbox. So all mechanical units are attached and on which the body is superimposed. Integral or frameless body type is represented here, in which generally such kind of a frame is not present. All the parts are connected in such a manner to form this body. So construction in which body structure is so designed as to combine the functions of the body and frame. The units normally attached to the frame, then being attached directly to the body. Generally it is in the case of all closed car that all the parts are connected with each other. If we compare with the conventional frame, all the parts, important parts, are fixed with the frame itself. So there are some of the advantages and disadvantages of frameless structure. First is the weight is, if we consider advantages, weight is reduced and consequent saving in the fuel consumption. So this is very important point, that if weight is reduced, then it helps in saving the fuel consumption, it improves the mileage of the vehicles. Then lower manufacturing cost, means we need not to put many more expenses in case of the conventional frames. So during collision or accident, the body crushes, thereby absorbing the shock due to impact and thus providing safety to the passengers. This point is very important in case of the safety of the passenger, that the body is absorbing the shock, that doesn't transmit that vibration to the passenger. Then compared to frame construction, the lower body position may be obtained, and thus resulting in increased stability of an automobile. And generally in all the conditions, while in motion, the body of the car, it is stable in all the situations. So let's discuss some of the disadvantages of the frameless construction. If its weight is reduced, mileage is increased, cost is also less, but here it is a reduction of the strength and durability, because if we compare in the previous slide the conventional frame, this frame provides much more strength to all the parts and the occupants. So here strength is less, durability is also reduced. It is economical only if mass production is adopted. So for that number of pieces to be manufactured here in case of this frameless construction, and then increased cost of repairs, no doubt, because all the parts are connected in such manner. If somewhere any defect or repairing work is needed, then cost of the repair, it increases in case of damage to the body parts. Next disadvantage, that topless cars are difficult to design with the frameless construction because of reduction of the strength and durability. So here one of the frame structure or frame construction is shown in this diagram. You just observe it very carefully. First of all, steel is used for press frame, and that is mild steel, carbon steel, and nickel alloy material sheet. So generally what happens, a simplified diagram that is representing the frame, it shows the longitudinal members, all these in one axis. These are the longitudinal members, and these are the cross members which are connected with the longitudinal member. These are the cross ones. The frame is upswept at the rear and front to accommodate the movement of axles due to springing. It also keeps the chassis height low. The frame is narrowed down at the front side, either as shown in this diagram, and here the dumb iron to act as a bearing for spring shackles here. So generally a normal composition of the material is represented, which provide the strength at various conditions of load